So we're at the Roanoke Regional Water Pollution Control Plant, and this is where we treat the valley's wastewater. So anything that is put down an internal plumbing drain from a home or a business in the entire Roanoke Valley is going to be coming to us through pipes to be fully treated. And it's about a 24-hour process from the time the flow enters the plant until we can have the liquid water fully treated and ready to go back out to the Roanoke River. Solids treatments take even longer, and the solids can stay on the plant for as much as 9 months. So this facility was originally constructed in 1951. Before that, there may have been a few neighborhood sewer treatment plants, but for the most part, people just sent their waste straight to the river. And so as you can imagine, the Roanoke River was much more polluted at that time. Since the 1950s, the plant has expanded and started to serve more localities. So we now serve the entire Roanoke Valley. We're able to fully treat any flow before it goes out to the river. And we have all benefited from that clean river. People get out, they go to the rivers, they go on the greenways, they look at the rivers. We use the rivers as a marketing tool in our valley. So the plant improvements that we've done over the years have helped that. We have the Archimedes screw pumps, or our Headworks, behind me. And this is where we lift flow from the sewer lines that are coming into the plant. And these sewer lines are the ones that are connected to all the residential sewer lines in the valley. We lift the flow up so that we can have it flow through the plant by gravity, and we can begin its treatment in the most efficient manner possible. Each of the Archimedes screw pumps can pump 40 million gallons of flow a day. Now our average flow is about 37 million gallons a day, so we don't always need all of them, but we're able to turn on the number we need, anywhere from 1 to 5, to meet the flow that's coming in. During wet weather events, sometimes rainwater can penetrate and get into our sewer lines. It's not supposed to. Rain's supposed to flow through stormwater pipes directly to the river untreated, but sometimes that rain can enter a pipe, or sometimes flow rates do go up, and so we have treated as much as 146 million gallons of flow in one 24-hour period here. In cases like that, we have to turn on multiple screw pumps to be able to pull that flow out of the collection system sewer lines and get it into the plant so it can be fully treated. Flow comes up the Archimedes screw pumps and enters into this building where we screen it out. It's almost like we have a large kitchen disposal up there that grinds up and then screens out any non-organic matter, food waste, plastics, toys. We get all kinds of things that come down the sewer that aren't organic and cannot be treated. So those get screened out here. That comes down this large pipe, goes into the dumpster, and then that material is taken to the landfill for disposal. As the dumpsters get full with grit and debris that has been taken out of the sewage flow, we will take those dumpsters to the landfill and dispose of that material. And then we have to bring back the empty dumpsters so they can be filled up again. And this is a process we do throughout the week. So the building that we have on my right-hand side here is our blower building. This plant has a staff of about 75 employees that work for us, but an untold number of microorganisms that work here. And the blowers are blowing air out into the aeration basins to provide the best living condition we can for those microorganisms, to give them the air and the oxygen that they need to thrive and survive and consume the organic matter that is in the wastewater flow. We came here at a great time because we actually have one of our septic haulers here at the facility discharging their load. So in addition to receiving all of the sewer that comes through pipes that are connected to people's homes and businesses that are coming through the collection system, individuals in the area that have septic tanks also have their sewage treated here. So the septic haulers will be contracted by the homeowners to empty out septic tanks. They bring that load here. It is discharged at the facility where it mingles in with the rest of our flow and receives the same full treatment as the flow coming through the collection system pipes. We receive about 300 loads of septage from these septic tank holders about every month. This is called the primary stage, and here at the Water Pollution Control Plant we have 3 distinct stages of treatment. So these primaries have flow in them, and as you can see, there's stuff on the surface that we want to get rid of. So the skimmer will come across the surface of this, get rid of all this material, and then it will drop down to the bottom and scrape all the solids that were heavy and sunk to the bottom. So we remove all this. Every step of our treatment process involves a specific removing of one item, and then it goes on and it keeps getting cleaner and cleaner as we go through the process. So these are the aeration basins, and this is where we have the microorganisms living. This is kind of like the high rent district for the microorganisms. It's everything they want. It's the temperature they want, it's the living conditions with lots of air, there's lots of food value in here, and they are happy in consuming organic matter in here. So the microorganisms are going to be consuming organic matter that comes through the flow. They're going to be in here for about 4 to 6 hours to remove as much of that organic matter and get the flow ready to go on to the next stage of treatment. This is called the aeration basins because of all the air that has been pumped in from the blowers. One thing to note with these aeration basins is the color. The color does not come from what you think the color would originate from. The dark, rich brown color that we see comes from all the microorganisms that are in this basin, giving it that color. After the aeration basins, the flow comes into the settling basins. And this is not a great place for all of our microorganisms. There is no new food value being introduced, there's no air coming in, we're not adding warmth to the water, and they start to die. And we take advantage of that. When microorganisms die, they lose their flagella, they're not able to motivate and swim around. They develop a sticky coating on the outside of their cell wall. And we take advantage of that. We want them to clump together and attach to some of the solids and sink to the bottom. So here in this empty settling basin, you can see how we do that. The flow comes up the middle through the pipe in the center there, and then comes out into the basin. And then these arms will be slowly spinning around. They're going to be moving the water and therefore moving those microorganisms, causing them with their sticky cell walls to bump into each other and to bump into other suspended solids, get heavy, and sink to the bottom. We are then separating cleaner water on the top and solids at the bottom so that we can have cleaner water to continue moving through the treatment process. Let's take a look at a basin that has water in it to see what it looks like. So now we're looking at one of the settling basins that is full of water. So this is the part where we start separating the liquid treatment process and the solids. So the liquid water that is spilling over the weirs here that has been partially cleaned is going to go on for more treatment in the third step of our treatment process. The solids are going to sink to the bottom. Some of those solids that have the dying organisms in it are going to go back into the aeration basins. This is how we replenish our microorganism population. And once they get back into the aeration basin with food, they're able to start eating and reproducing again, so we have more organisms. The other solids that are down here will go on for solids treatment through the rest of the plant. So in the coagulation basins, it looks very similar to what we saw over in the settling basins. But the big difference here is we're using chemical treatment instead of something organic. Here we're adding ferric chloride to the water. The water is still going to come up through the center of the pipe in the middle of the basin. We're going to add the ferric chloride, which is an iron salt, and that is going to cause any small particles of suspended matter to bind together and sink to the bottom. Again, we're sinking solids out at the bottom and we are getting clearer water at the top. So the water spilling over these weirs is exceptionally clear at this point. The main reason we have this third step is to remove phosphorus. And phosphorus can come to us from people using phosphorus in their detergents and their home, and personal care products or dishwashing detergents have phosphorus in them sometimes. We want to remove that phosphorus so when we put the water back out in the river, we don't have phosphorus that could promote algae growth or other aquatic life that may be harmful. So this is the filter gallery, and this is the last step in cleaning the water that comes through the wastewater treatment plant. So behind me, we have 10 filter units. And this is really mimicking what the earth does so well. Water will run down through layers of anthracite sand and different densities of sand to filter out any remaining particles in the water. And then the water can go on for chlorine disinfection. So after the water comes through the filter, the final step of treatment is to disinfect it. And we add a dose of sodium hypochlorite, which is just like a really strong bleach solution. That kills any remaining pathogens, anything in the water, and disinfects it. We have the water come into this chlorine contact basin, and it spends about 30 minutes with that bleach solution. And as you can see, the walls inside this contact basin are completely all the way across. That's so that the water can weave its way through these baffles, giving it plenty of time to spend with that chlorine. At the end of this process, we are going to remove the chlorine. We're going to use sodium bisulfite that is going to neutralize all that chlorine, because we do not want to put chlorinated water back out in our Roanoke River. Here at the Roanoke River is where our treated water goes back out into the river to be used again. This is like the ultimate recycling. We're taking dirty sewer water, cleaning it over about a 24-hour period, and then putting it back in the river where it can be used again. We have all of our treated flow comes through this one pipe here out into the river. And as you can see, this is very, very clean water. It's much cleaner than the water flowing down the river, but it is our goal to put water into this river that will support aquatic life, that will provide ample recreational opportunities for our citizens, and ultimately become drinking water farther down the river. We actually add about 60% of the flow of the Roanoke River by coming through this plant and being clean. So we're proud of the job that we do cleaning up the water that will support our valley and others downstream. So one of the things that happens here is we have solids treatment, and the solids that settle out during the first part of the liquids treatment process go into the digester. And I like to say that's like the stomach of the plant. You have microorganisms that are consuming organic matter. It's where anaerobic digestion happens. And as a byproduct of this consumption, carbon dioxide and methane are produced by these organisms. The domes capture that methane gas because that is a fantastic renewable use of energy. So after all the solids go through the digester, they still need more treatment. And so they go out into our lagoons. And we have 5 lagoons. It's about 23 surface acres of space where we hold this thick, solid substance. It's almost like the consistency of wet cake batter. Microorganisms continue to break down the organic matter. Sunlight helps break it down. During the summer months, after this material has been in those lagoons for a while, we pump it out and we haul it down the road and we land apply it as a fertilizer on farmers' fields. It is no charge to the farmer, and it is all inspected and monitored by the Department of Environmental Quality to make sure that the process is working the way it should. In turn, the farmers get to have very nutrient-rich material added to their farms, and their non-food crops that they're growing, like hays and straws, benefit and they get better yield.